Good afternoon, or indeed good morning, good evening, wherever in the world you might be joining us from today. Welcome to another PV Magazine webinar. And thanks a lot for joining us today. As always, we have a great show lined up over the next hour. Our topic today, still among the most important issues in the PV module sector, is the transition to larger wafer and cell formats. Beginning, I think, as far back as 2018, this transition is now well underway with the two large formats, 182 millimeters and 210 millimeters, together representing about half of the silicon PV cells on the market last year. And that share set to grow further, indeed already growing further in 2022. And when it comes to the benefits gained from this switch, the much higher module power ratings, the reduction in balance of system costs, and in overall levelized cost of electricity, much of the analysis to date has focused on the large-scale solar segment. But of course, if wafer formats smaller than 182 millimeters begin to disappear from the market, as many manufacturers and analysts forecast, modules for the rooftop will also be very much impacted. And this generation of modules for ground-mounted projects with 500 or 600 watt power ratings is widely seen as too large and too heavy to meet the requirements of a lot of rooftop solar systems. Manufacturers, however, are nothing if not adaptable, and how they are adapting their offering to the rooftop segment will be our focus for today. Working with the 182 millimeter cell format, LONGi Solar has come up with a 54 cell, 400 watt module that it calls the little brother of its already well established 72 cell HIMO 5 product. And joining us in just a moment, we have Winfried Wahl, Head of Product Marketing at LONGi Solar, to take us through this new module and its features, packaging the advantages of a larger cell into a module that's a little less unwieldy for installers working in the confined space of a residential or indeed a commercial rooftop. Welcome, Winfried. Great to see you.
Hi, Mark. Thank you very much for having the opportunity to speak.
Thanks, and more coming up from Winfried in just a moment. And after that, expanding this beyond the module itself, we also have Aymeric Barrett, Technical Director at Skyray Engineering, joining us to take a closer look at how this latest generation of modules for the rooftop segment, still bringing quite a jump in power rating to the 400 watt range, will influence the overall system design and how energy yield can best be optimized here. Welcome, Aymeric. Great to see you as well.
Hello, Mark. Hello, Winfried.
Well, that will be today's webinar. I will hand over to Winfried, first of all, in just a moment. First, though, a couple of housekeeping points from me. We are, of course, broadcasting live today, so please do send in your questions for both of today's speakers using the questions function on Big Marker, our webinar platform. I will be feeding your questions into the discussion after the presentations, so please don't be shy, and we will try to get through as many of your questions as we can in our 1 hour slot this afternoon. One question that I will quickly answer now is that, yes, the recording and the slides from today's program will be available afterwards. These are emailed out to all who registered shortly after we wrap up today, and you can listen back to the webinar at your leisure at pv-magazine.com/webinars. Here, of course, you can listen back to all of our past webinars and have a look at what we have coming up. Plenty of great webinars on the way in 2022, so please do check those out. For now, though, I will hand over to Winfried Wahl of LONGi. Winfried, over to you, please.
Thank you, Mark. It's my great pleasure to introduce our 54 cell, as you already announced, of the HIMO 5 series. I will go through a bunch of slides, some of them, and especially the first two are explaining where we are coming from and why the industry is moving towards bigger wafers. Looking at the history in the very early days of solar, the wafer sizes were more or less determined by what's coming from the semiconductor industry. So we have been starting with very small formats, 125 millimeter, then for a long time, 2015 around. Dimensions around 156 have been in the market with some smaller optimizations. And just with the merging of the G1 and M6 wafer formats, which are you can see on the middle part, the solar industry has defined their own sizes they want to work with. And however, the trend has not stopped with the 166 M6, which was quite a standard for a while. But it's, as Mark already indicated at the beginning, it's moving to bigger ones. So the industry itself, solar industry, defines what they think, what they believe is the optimum size for PV module and PV power plants use. There is another information chart by PV Infolink, which underlines the history. If you just have a look at the bright yellow part, that was the M6, which at least the last 2 years had a market share of almost 40%. That is going to be replaced by the bigger format, by the 182 format, which is as well called M10. So already in 2021, that had a market share of 28%. And for this year, we expect that this format will take over the majority. It's always a bit difficult to look even further into the future. There's as well some competition between even bigger formats, which might as well gain market share. But any format which came from the old semicon industry, and as well the first formats based on 166, is likely to disappear in the time frame up to 2025. So what do you need to consider as a module maker to when you determine the optimum size? And it's a bunch of things. I don't want to go through all of them in detail, but I just wanted to give you an overview. It is not just the module nameplate power. It's technical feasibility and cost, which is very important. It's reliability, and that's something where as well there might be an upper limit on not getting bigger and larger. Mechanical loads coming from wind and snow loads, as well dimensioning, bypass diodes, junction boxes design. They are some boundaries which need to be considered. As well, system compatibility. So at the end, it doesn't make any sense to develop a module which cannot be mounted. And we have to consider as well terrain, tracker systems, cabling. Another point which is maybe less relevant for installing or for end user, but there are as well limitations coming from transportation. For example, that if you have a double stacked pallet in the 40 HQ overseas container, there is a maximum module width. Otherwise, you would not be able to stack 2 pallets on top of each other into the container. And last but not least, as well, we have to have a look at installation practices, installation time and cost, handling, things which are related as well to weight, racking costs, which have to do with, let's say, the bigger you are, the more mechanical forces are coming from the module, the more you have to strengthen the racking. And if you consider all of that together, LONGi has a clear opinion that 182 is a kind of the optimum what can be done in regards to increasing the wafer at the same time, considering those boundaries. Even if we are talking about a new product today in the second part of the presentation, HYMO 5 has been winning the Intersolar Award in the last year. We are talking here about the big brother. I pick up the wording from Mark. The big brother HYMO 5, which is a bifacial product and has had a bunch of benefits based on the M10 182 millimeter wafer, which are in regards to power and efficiency, but as well using interconnection technologies like smart soldering technology. So we have already been happy to have received that award last year. In regards to track record, I can say that already back in November last year, we have exceeded with the HYMO 5 series the sales milestone of 10 gigawatt sold. And there are a few details I don't want to bother you with, but it is worldwide spread. So shipments have been made to more than 600 countries and 600 customers in over 50 countries in the world. So it's not a new thing, something where you go any risk. It is mature technology, and we are just bringing it now to the rooftop segment, to the residential and the commercial industrial applications. Another thing, thanks PV Magazine, who has as well tested our product in regards to a bunch of characteristics. As well, I will just pick a few of them. Looking at, for example, LETID loss grade, which is the most right bar, is a green bar there. This is indicating then when the module has been exposed to light at higher temperatures, at elevated temperatures, there was virtually no loss. So older technologies had the problem that after some light exposure, the module started to degrade. Almost the same good. There's a strong resistance against PID, potential induced degradation coming from the voltage. And product as well performs very good at higher temperatures and at low irradiance. Just keep that in mind, that the detailed report is available in the February edition of the PV Magazine for reading, because some of those argumentation will repeat in the next slides. Going further, I'm really now proud to introduce a new family member, the little brother of the 72 cell, which has been used very much in large-scale utility applications, in tracker systems and fixed tilt systems. So this one is going to be smaller, 54 cell, as it has been said, but it's a proud member of the HIMO 5 family. The 5M stands for that it's a single-sided monofacial product, so it's not bifacial like the big brother has that option, because we have the roofs behind the module, so there's not too much of the bifacial gain or yield coming from the rear side. But it already copies some of the advanced technologies which have been implemented into the 72 cell product. So it's using the same M10 182 industry size wafer format. The cells are gallium doped for lowest light aging. So I referred to LATID, which has been hardly been measurable. The module efficiency is over 21%. It's standard mature P-type PERC technology with 9 bus bar design. The module format as well follows a standardized size, and for the 72, you maybe remember that big industry players agreed on the same format, that modules get exchangeable, that there's a kind of a standardization which makes supplier selection easier. As well, that little brother follows the standardized module width of 1134 millimeters. For rooftop applications, it comes with long cable, 1.2 millimeter. You can as well select the shorter one if you like. And for the distributed generation, which is our rooftop business, as well, it comes with the well-known Stoibli MC4 Evo 2 1500 volt connector. Or if you like, in bigger applications as well, there's a LONGi LO5 connector available. Mechanical loads I will touch in more detail in some slides to come. So we are going to bring those two variants into the distribution business, distributed generation rooftop applications. One is a standard module, which is based on a white backsheet. You see the dimensions there. It has a black frame. The size is 1.95 square meters, well below the 2 square meter limit. I will explain in a few moments. And the power range, Mark mentioned above 400 watts, so it's going to be 405, 410 at the beginning of the shipment, and in the peak, it might as well reach 415. So a perfect product for residential and C&I sector. On the right-hand side, you see the all-black version. The only difference to the left one is that it doesn't have a white backsheet, it has a black backsheet. which allows customers which have higher aesthetic requirements to have a homogeneous roof design. Moving forward, I'm as well going to show you a bunch of product advantages. They are grouped in 3 sectors. One related to better performance, which I'm going to start with. Then reliability on rooftop product size. I will go into some details, which I touched at the beginning. And in the last part, I will cover the topic quality and customer benefits. So the excellent energy yield, you remember this as well, this graphics from PV Magazine test. It is important that the module performs well. So not just the module nameplate power, but as well the power generation over the day is of importance. In the morning and in the evening, it's when the sunlight approaches the module under a very low angle and lower intensity, it is important that the module has a low irradiance performance so that it performs well under these conditions, that it has a good temperature coefficients when it goes around noontime. When temperatures go higher, the module heats up, especially the black cells will trap as well some temperature and heat up. And IAM, that stands for incident angle modifier, that says under which angle the sunlight touches the PV module, there is a high conversion rate into the module, and at the end, as we said before, low degradation. So there is virtually no light aging, a strong protection against the potential induced degradation, so that the module power and electricity generation stays very stable over the lifetime of the product. I want to show you a little bit of some details. Here on the left side, on the lower part, you see the integrated segmented ribbon. Integrated segmented ribbon because the ribbon is not the same over all the lengths. It has a triangular part, which is on top of the cells. The reason for that is that there would not be any reflection coming from the ribbon, but it helps that the light goes into the cell instead of going out of the module again. And then you see these 2 red circles here. The left one is the pyramid structure, which we have on top of the cell. And in between of the cell, the ribbon is flat. The reason for that is that due to some temperature cycles, the materials are expanding and shrinking, and to keep the stress for the cell as low as possible, it is very much advisable that you go with a flat ribbon in that section, because it can expand much easier and it can shrink when it gets cooler again. So on the right hand side, the graphic, you see the forces which are coming from an integrated segment ribbon to the cell compared to a standard round ribbon. So at the end of the day, there's a significant reduction in mechanical forces inside of the module, which increase the reliability. The product warranty, I think that's quite standard, or it's standard for our products. So the year 1 starts at 91%, and then you have a slope which is 0.55% maximum degradation per year. Please keep in mind this is a level which we warrant as a manufacturer. The real life degradations should be much less, especially in moderate climates. I'm in Munich, for example. There over the years, the degradation is hardly measurable, and so for best educated guess, you could maybe for the power calculation assume 50% of the level, which is the safe side of the manufacturer. So it comes with 25 years warranty for power generation. And the third thing which I would like to mention as well is that for larger projects, our products can be reinsured by Munich Re. This is especially if there are bigger projects with multiple sites of interest, that this insurance backs our warranty, and as well backs in case of the very unlikely event of an insolvency. That option exists to back our modules with the Munich Re insurance. Next one. This is the point where I would leave much of it to Emmerich because he's an expert in handling those. But let me allow to give you a small overview here. When we designed the product, we have been taking specially care that any relevant mounting method can be applied to the module. The module is fixed on the long side using 4 clamps, which is quite typical for residential roofs. The mechanical loads there are given. These are test loads. These are not design loads. Those of you who know that for designing a system, you have divided those numbers by 1.5 to get to the design limits. Important to say here as well is that the module can be fixed on the short side using 4 clamps. If you do it like it's illustrated in the picture, then you have 2,400 Pascal plus minus. So that means push and pull forces of that level, which equal around 250 kilograms per square meter in both directions. If it even comes to the most extreme and the most challenging part of a module to clamp it on the short side on the edges, which is very much used on commercial and industrial flat roof systems. Even there, the pull forces, 2,400 Pascal can be applied, and suction forces of minus 1,800 Pascal. Why is that number a bit lower? It's clear that most of these flat rooftop systems are aerodynamic design, so the impact of the wind there should be slightly less than if it's completely exposed to, for example, in a ground mount installation. Inverter compatibility, just to mention, we have spoken with many of the inverter manufacturers, the big name and brands across Europe. You can see here that the current at the maximum power point is roughly 13 amps. Most of the even older design inverters can easily deal with 12.5 amps without any problems. Just keep in mind that these numbers given there are at standard test conditions, so these are lab values. The real current values and the real power generation might be lower. So even if you compare datasheet with datasheet and some numbers seems to be slightly lower than given by the inverter, speak with the inverter guys and they will give you the confirmation that this module can be used. Newer inverter designs anyhow will be able to deal with higher currents. Yeah. So we are staying well below 15 amps, which is expected to be the next level for inverters. Another part to be mentioned, the lengths and some of the mechanical things. I don't want to go through all the details. You can read in the documentation afterwards. Just 2 points to highlight. The area with 1.2 square meter is below the German limit from the building codes, from the building regulations, where modules for residential and rooftop applications must remain under 2 square meter of size. So that's why we choose this design. In regards to handling, the module weight is 21.5 kilograms. So it's still possible to be handled by a single person. I'm just giving you some indications there. What is the limits by different regulations? For sure, they vary country by country, but until 23 kilograms, you're quite sure that you would not need a second person by regulation to carry those. In the real installation on the rooftop, definitely there's more than one person for fixing, but we as well respected those boundaries, those limitations. If you want to read more, on the left side, I've given you a link, for example, from UK for health and safety regulations, where as well the picture is taken from. in regards to quality, I just want to repeat that the HIMO 5 products already have received different awards. Looking at the left side from PVEL, which is doing a kind of a reliability scorecard, doing a bunch of measurements, different measurements to test and verify module quality. LONGi products have been awarded top performer. That is not the first time. I think it's the fourth year in a row when we have been received that top performer score. And as well, if you look at RITC, which is a leading engineering service and certification company in the US, we have been the high achiever with that modules and module technologies. On the right-hand side, the graphic with the 3 circles shows you a little bit more what has been tested. It's a combination of performance, so module efficiency, light-induced degradation we had before, PV-assist simulation files, so that they are typically used to calculate the yield for larger installations, but as well reliability, doing double IUC testing with damp heat, for example, at 2000 cycles, doing dynamic mechanical loads, which is actually vibrations, potential induced degradation, I've mentioned to you already. And the quality as well is those test labs as well do a combined testing, whether they call it treasure test or something else doesn't matter, but it's not a single test sequence from the IEC, but it combines, for example, humidity freeze with 3 times the cycles which are given by IEC, temperature cycles 3 times, damp heat, as well as UV soaking. So those modules have been really put under some harsh testing to make sure that the quality is in line with our expectations and as well giving you a good product for your application. Last but not least, I would like as well to mention our internal LONGi life cycle quality system. I will not go through all the details there. That will kill my last 2 minutes, but just to give you the cornerstones that in regards to design, electricity, electrical values, mechanical things, optics, those are very well controlled. We do a lot of experimental test results, and we have a lot of historic experience. We do a lot of analysis before we select the product design. We are as well, the second point, in regards to materials, do very intensive testing before materials are allowed to go into the modules. We select our suppliers, which are very reliable as well in regards to financial strengths, because we want to have long-term relations with them. We do a lot of planning, which means to ensure continuity, for example, in production, that we have products which are or components which are exchangeable. If there's a shortage with one supplier, that we can strengthen the supplier B and supplier C, but the material characteristics are very much the same. Reliability testing, for sure, we do it internally. I've shown you on the slide before, reliability testing by external partners. We have highly automated production lines, quality assurance, multiple checkpoints, many times where EL is controlled. And we really implemented this LONGi lifecycle quality management system over all our production sites in the different regions and countries where we have production. So I hope I could give you a brief introduction into the little brother 54 cell, which is really from the dimension point of view, from the mechanical things, from the electrical performance. I think the ideal product to be used on private, residential, commercial, and industrial buildings. If you have further questions, there will be a Q&A session at the end. Thank you very much for your attention.
Thank you very much, Winfried Weil from LONGi Solar there. Winfried, before we push on with Eimerik's presentation, I will squeeze a quick question in for you. So one of our eagle-eyed listeners, our viewers today, has pointed out that with M10 cells, most manufacturers have gone for 10 bus bars interconnection, but LONGi goes with 9 bus bars. Is there any particular reason for this?
I mean, we call all of them, everything which is more than 5, we call it multi-bus bar technologies. We have decided to do 9. At the end, it's always a compromise between cell shading and what you gain for that. We feel well with 9, and that's why we have selected 9. Some others might have a different opinion and go with more, but at the end, the amount of kilowatt hours produced is that what counts at the end, not really the number of bus bars.
Absolutely, very, very good point. Well, we should have plenty more time for questions at the end after our second presentation today. So please do keep your questions coming in, and I will be feeding them into the discussion as we go. Right now, though, I will hand over to Eimerik Barrett, Technical Director at Skyray Engineering. Eimerik, please go ahead. Oh, it looks like we just need a couple of seconds to get him on. Eimerik, are you with us?
Mark, Eimerik is just turning on his mic, and he is on now. Yeah. Go ahead, Eimerik.
Okay. Thanks. Sorry, I didn't hear you, Mark, before. I had to refresh. Thank you, Winfried, for this lot of information with this panel. I move on, Mark?
Yeah, please go ahead.
Yeah. Okay, let's go. So, hello everyone. I'm Eimerik Barrett, the Technical Director of Skyray. I'm going to give you a quick introduction to Skyray, then we'll move to the topic of the day. So, yeah, Skyray was founded by Everose, which is a well-known technical advisor in the renewable energy sector in Europe. And we are here to help owners to design, engineer great and sustainable solar PV projects that could be associated with storage. And we are delivering for these high-quality services. We are based in Lyon. I'm currently speaking from Lyon now. And we are based in Lyon, in Lisbon, with partners all over Europe, in UK, Spain, Germany, Ireland, and Italy. I will show you quickly. So this is, let's say, the ID card of Skyray, of the company. We are here to address the big need to design and build a large-scale PV plants that could be on rooftops and ground-mounted system. So with classic fixed tilt tracker, doing some agri-PV, floating PV also. We do so. We are a pure player on solar and storage engineering, and we are focused on design and construction management services. We do this with an experienced team with a lot of megawatt peaks already built in various countries. You can see our core services on the right of the slide that are divided in 2 main parts. The first one is design services to support owners in the development phase. And second part is OE, owner engineering services for construction. So it means mainly that we are doing some procurement support and construction management to ensure the quality, sustainability of the assets. So yeah, today we are here to speak about rooftops. Yeah, at Skyray we already have an important track record helping clients to ensure quality on their construction, and we are currently involved in providing procurement support, design review, and quality control during construction for various type of rooftops. That's it for Skyray. Let's move to today's agenda. So yeah, I hope you had a good nap before joining us, because we are going to dig in a bit in some technical details of the modules. We'll check together the consequences on layout design with these new modules, and we'll check electrical and mechanical impact that this new module will have on design. After that, we'll have a few minutes about good practices in design and construction generally. So first, we can have a quick look to the main mechanical characteristic of these modules. So I extracted here one on the left, the current typical 60 cells that you could use today on rooftops, and on the right, the new LONGi IMO 5M modules that we're speaking about today, with the M10 cells, which is 400 watt peaks. So what we can see looking at these two data sheets, the main output of this is that there are a lot of similarities. We have quite similar lengths with these modules, and we have a slightly larger module. It's around 10 centimeters. So it's not a big change here. We also have a similar efficiency, which is around 20.5% for each modules, and similar power density. So I mean watt peak per kilogram. Both modules are around 20 kilograms. The new module is a bit heavier than the current one. So again, no big changes on these aspects regarding mechanical characteristic. Also in the datasheet, we can see, and Winfried spoke a bit about this, that there are some similar performance at high temperature. Yeah, and it's still with temperature coefficients which are already good for this kind of module, the P-type module this year in 2022. I wanted to show you a concrete case study using this module on a typical industrial rooftop. So you will see in this presentation, always on the left, the current 60 cells typical modules, and on the right, the new M10 cells modules. So again, main outputs of this is that we have same module efficiency, so we keep a similar PV capacity in megawatt peak installed on both rooftops. If we take a closer look to this, we have the same module dimension approximately. So if we take a closer look, we have the same pattern of distribution, and yeah, it could change a bit regarding design rules, but it's quite similar again. Then we can move on the electrical perspective. I extracted you the main electrical characteristic of the two modules, current modules and new modules, on the right column. So it is interesting to see here that we have few difference on current and voltage characteristic. I would say that the main information here is that for similar efficiency, you will have lower voltage with the new model that will allow us, it will allow you to optimize string configuration. So it can mean cost and time optimization with the works and electrical cable lengths and other small equipment such as DC connectors. At the same time, if you have a lower voltage with same power, it means that you will have higher current. So just don't forget to check with the inverter DC input current that it will be a good match, and that the inverter is ready to plug with these new modules. I extracted you, if we have a quick look to these two typical inverters that we could use today, 60 kilowatt and 100 kilowatt. one is ready, allowing the 13 amps per string, and one would be too short for this module. So just pay attention to this during the design. If we go more in detail in this 100 kilowatt inverter, a concrete case of configuration, electrical configuration you could have. So here I just wanted to highlight what type of configuration it could be. The hypothesis I had here at first are to have a classic DC-AC ratio, so it's 1.2, 1.25 approximately. I stick with 1 kV DC voltage instead of 1.5, as we still see this configuration on rooftop, mainly because we try to keep the 400 volt AC outputs for self-consumption. And I used also a minimum temperature of -10% in this case. So the main result here with this configuration is that you will have more power with less modules, so as expected. And in addition to that, we'll have a bit more module per string, resulting in fewer string per inverter. And the calculation, it's approximately 15% less string with these new modules. So again, this is a concrete example of cost optimization using this module. On the mechanical perspective, if we go to have a look, the main differences with the current module, it will be that you will have to choose a good mounting system. Don't forget to check the technical specification from the supplier and mainly the permitted width, because indeed some mounting system, a lot of mounting system already accept this kind of module, but some are not ready yet. Sorry. So yeah, I expect if you're a mounting system manufacturer, you are probably already looking to this topic. And secondly, very interesting point mentioned by Winfried is that clamping. Here, the manufacturer LONGi allow you to guarantee the clamping on the short side of the module, so it could be helpful in some cases. After all these module-specific comments, I found it interesting to have a quick look to good practices to optimize design, cost, and long-term efficiency with your PV plants. So I'm sure you're all aware of most of these, but still, it could be helpful to have a look. So the first point is quite related to the choice of modules, the topic of the day, which is the string optimization. We recommend for sure to optimize the number of modules per string to match the use of minimum temperature on site with the maximum inverter DC input. Second point, which is a big concern for developers today, is how to optimize grid connection cost and DC power capacity. So we just here recommend not to stick with a fixed good practice DC-AC ratio and try several configurations because sometimes few curtailments will allow you to have quite significant higher DC capacity with your project. Then finally, probably the most common and important good practice to keep efficiency on the long term and optimize the maintenance cost are first to prefer tilted PV module to prevent from soiling and water infiltration inside the modules. Just a quick reminder, if you're on the flat industrial rooftop, always plan to do a proper wind stability study in execution design phase. And finally, the last word for today's topic is please don't work on the module when you're doing the installation, even on the edges, the border, the corner, during construction and maintenance phase to avoid micro cracks. So in fact, even if we don't see them at the beginning, it could cause some defaults and lower performance in the long term. So in brief, we are on very similar design perspective here. Just plan to check the mounting system and inverter specification. These new gen modules should allow to optimize construction costs if designed well. And yeah, this specific warranty to fix clamps on the short side of module could help to build projects on wider range of rooftops. So I will conclude, and it's good because I have no voice anymore, that the sweet spot of this technology is clearly rooftops installation, as it looks like a very good compromise regarding power, dimension, and weight. So this is it. You should be able to read again all the slides. I know it's quite a lot of information. Thank you all.
Thank you very much, Imric. Great to have you. Great to have some more detail on how these modules fit into an overall system design. Well, now we have a few minutes left over for Q&A, and our audience have sent in a fair few questions already. And well, I think we'll start with what should be a fairly easy one for you, Winfried. When will this module actually be available? What is LONGi's plan for the rollout? Particularly people asking about Europe, also India, perhaps unsurprising given the time zone we're doing this in.
Yeah, the production has already started in February with the first quantities. So for most of the versions, most of the European countries, production is already running. There's a few sub-versions which are being released beginning of next month. So we are not announcing something which is far away. The production has already started. I cannot speak for India because I'm in charge of Europe, but I assume since India is as well an IEC country that if that gentleman or lady who's asking that question contacts our local people in India, they would be able to answer that question more precisely. We are launching in Europe first, and but I would assume that as well India will catch up very soon.
Okay, yeah, that's pretty clear. Another thing in your presentation, Winfried, you mentioned this is only a monofacial module at this stage. Would there be plans to launch a bifacial module for the rooftop segment as well?
Yeah, it always depends on the demand. I mean, most of the traditional rooftop installations are done with monofacial products. And we are as well thinking about next generation of products already today. And it's always a question how big the demand is. It's not a big deal to make as well a bifacial module on a smaller format, maybe not on 54 cell, but it depends. It's a matter of to justify production. And the 72 we have at the other end of the spectrum today exists as the bifacial version. We might expand as well that product family, getting some more sisters and then maybe another brother in between. And it could be that one of those products would be available as well as a bifacial thing. Not for now, but let's say it would be good if that request would be forwarded directly to me, that we can as well think about having a bifacial option and to quantify the demand.
Okay, absolutely. And Imric, do you have anything to add on do you see much growth in demand for bifacial in the rooftop segment?
Well, I know for sure that Winfried will have some demands from the client for bifacial and rooftop because some clients are trying, some new thermal reflect solution with white roof, and it could be, in this case, interesting to have a bifacial modules. So in some cases, I expect could be nice.
Okay, certainly. Now another topic that's been pretty popular among the questions that we've got is the warranty. So Winfried, first of all, this module comes with a 25-year warranty. I think was in your presentation. We see a few manufacturers today offering 30-year warranties. One now even launching a 40-year warranty this year. Do you see these as realistic to go beyond 25 years?
Yes, let me give you a very easy answer. Our double glass products, whether bifacial or not, already come as well with 30 years performance warranty. The glass foil is limited to 25 in our strategy. I know that many customers are planning this longer useful lifetime, especially on the EPC business on utility scale, because if you can calculate this 40 years instead of a 30, then for sure the LCOE will be dramatically lower than if you have a shorter lifespan calculation. The question is if the manufacturer has to cover all of that. So at the moment, it's really for glass foil constructions, we provide 25 years. For glass constructions, we provide 30 years of warranty.
Okay, sure. And Imric, as someone building systems with these modules in the field, how do you see 40 years realistic?
Of course. No, I mean some modules that are 40 years old are still working. So for sure, the clients, they are doing their business model regarding 30, 40 years for some. So if they could have a warranty going through all their financial models, they would be very happy. But I can understand that 25 years, when you're speaking of something you will install tomorrow, is already a good thing to have.
Mm-hmm. And maybe let me give you another, or return that with another question. If you buy a car, and maybe if it's a Renault or something like that, you get maybe 8 years of warranty, but everybody knows that you can drive 15, 16, 20 years if you treat it well. So it's really a question if that needs to be in line. On the other hand, the longer you do the warranties, the more cost as well you have, because you have to build accruals, you have to do the reinsurencing. It makes sense to calculate with a longer lifetime, and if there are concrete requests, please address them to us. If we can go or provide some solution that might compromise on that.
And when it comes to the degradation rate that's specified in the warranty, I mean, in your experience, do modules in the field track close to this in their degradation, or perform a little bit better? Or?
And that very well depends on where you are. I mean, if you're in a very hot and humid area with very high temperatures, then degradation is definitely higher than if you're in the UK or in Germany, where you have real degradations of something like, I don't know, 0.2%, 0.1% per year. So the way to answer that question is, it depends. It depends on how challenging the environment is for the module. It can be close to nothing. If at the same time as well the global irradiation increases, then the modules are performing more or less the same year over year. We have done some analysis before, and the numbers were way below the level we put on the warranty, because for sure the warranty should never come to be needed. So it is a very defensive approach and should reflect the worst case.
Okay, and for now, you mentioned the difference in warranties with the glass product. Is this 54 cell module only as a glass backsheet product for now?
For now, it's we're launching it as a glass foil, glass backsheet construction. Yes.
Okay, and would glass be possible there, or would you be getting too heavy then for the rooftop?
That is exactly the good question which we are running analysis at the moment. If we could, this module has a 3.2 millimeter glass, heat or tempered glass. If it is possible to do it with 2 times 1.6 millimeter to be weight neutral, it could be a good approach to replace then the glass foil construction with a double glass construction. But we don't have enough data yet. It might be something to come in the future.
Okay, and I think that covers the warranty topic pretty well. Thanks a lot for your answers there. Another question relates to inverter compatibility with the higher voltage of these modules. I don't think there's any problem with string inverter compatibility, but how about micro inverters that we see in the rooftop segment sometimes?
Emmerich, do you like to answer?
Yeah, I see no issue for sure. Just especially the micro inverter, they are typically designed for one range of module, and so I expect just check the data in with the technical specification, and if you're in the range of voltage and current, it will be okay. And I'm sure that if that a lot are already ready to accept this kind of modules.
Okay, certainly. Thanks, Imric. Did you have anything to add there, Winfried?
No, the current is the same. The current depends on the cell technology and the cell size. So current should not be a bigger issue, especially looking at the whole industry moving to this the sizes. So if there are microinverter guys who have been using older designs, it is the same as with the mounting structures as well. The BOS component suppliers need to adjust to the market trends, and the ones I've spoken with, there's not a big deal. But as Emmerich said, you should check whether the brand you have in mind is already complying to this new generation of modules, which are going to be dominating the market in the future.
Okay, great. Well, we are coming up to the end of our 1 hour slot. I will squeeze, at least one more question in there. One listener has noted that this module comes with a decreased frame size and asks what is the impact here for the mechanical strength on the mounting system.
A very good question. I really like that one because the application requirement or the system requirement is the mechanical load, and the frame height is the answer. So we have given R&D the task to fulfill the mechanical requirements, as we mentioned, and same time optimize the frame. And the very positive result is that we can reduce the frame height to 30 millimeters, which has a bunch of benefits like higher packaging density, lower transportation cost. We all know the transportation cost in these days plays a significant role. So yeah, thanks to the R&D guys who have made it possible to achieve the design targets on the mechanical side, even with a more compact frame, which is possible with 54 cell. The big brother has a 35 millimeter frame that's too large to be possible to cover the loads with a more compact frame. But very well. Listening to or looking at the numbers, I didn't even mention the 30 millimeters. It is the little brother is a little brother because he has a little frame as well.
Well, yeah, great. Thanks for sending that question. Then great that people are paying attention. And I think that is a great place to wrap up today, as it's just turned 4 o'clock. Thanks once more to Winfried and to Imric for your presentations today and for sticking around for the Q&A. Thanks also to all behind the scenes at LONGi and at Skyray, of course to my colleagues here at PV Magazine as well, for working to put together a great webinar for this afternoon. And thank you finally to all of you for joining us today and to all who submitted a question. We really do value your contributions to the discussion. And my apologies again that we can't quite get to all of the questions that were asked today. Otherwise, well, we see coming up to your screen now the February edition of PV Magazine, where we had a close look at e-mobility and all the issues there. Vehicle integrated solar, a couple of really great articles on electric vehicles in there, and we have now just finished work on the March edition that is coming out next week. Plenty of great investigations into cell and module technology in this magazine. A strong focus on TopCon we went with, where there's several gigawatts of production coming online this year, and we've put together a couple of articles on how we got to this point with this technology and what is still to be settled and standardized on those production lines. On the rooftop side as well, a great update from our editor-in-chief, Jonathan Gifford, on PV in Turkey, where big demand from the commercial sector is driving a comeback in installations this year, and lots more in the magazine, of course. We've got the latest on plans to establish a PV manufacturing base in Europe, in India as well, and some other regions also. Lots of good stuff on PPAs and unsubsidized PV growth in Europe. So don't miss out on those and much more in our March edition. That's coming out next week, and you can head over to pv-magazine.com to pick up a subscription. Plenty more great webinars on the way as well tomorrow, or well, very late tonight, I think, European time. Of course, you can listen back anytime. The excellent Bella Peacock down in Australia will be talking reliability. And well, what we briefly touched on this afternoon with the first 40-year performance warranty offered for a PV module. And then next week, next Wednesday, Maria and Tristan, our editors here in Berlin, have a great show on residential storage for you. So don't miss out on those and the many more webinars that we have coming up. Head to pv-magazine.com/webinars to register and to see what we have in store. That's it, though, for today. And any second now, there should be a very short survey that will pop up on your screen, just looking for some feedback on today's program. We really do appreciate if viewers can just take a minute or two to fill that out. Your feedback is really valuable to us. So thank you in advance for that, and we hope to see you at another PV Magazine webinar very soon, though. For now, though, that's goodbye from all of us.
Goodbye.